We are starting Module 7, which is all about exponents. So for Algebra Lesson 7.1, I would first like you to start by looking at this table of exponents right here. It's a little dark, it's a little hard to see, so try to fill it in. And if you're watching this video in a spot that you can go ahead and pause it and see if you can fill in the answers to what 2 to the 4th is, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and feel free to use your calculator if you need to, but take a minute now and fill in this table and then push play and check your work. Okay, as you're filling this in, I told you guys you could use your calculator. So a really quick review of how to use your calculator when you're talking about exponents is this little caret key right here. This means it's raising something to a power. So when I want to put in 2 to the 4th, I'm going to push 2 and then this little exponent, and it ends up looking like that, and then a 4. So this represents on my calculator 2 to the 4th power. And that is 16. And what that means is 2 times 2 times 2 times 2. 4 of them, 4 2s, 2 times 2 times 2 times 2. So I know you could probably have done that in your head too, but I want you to see both ways to do it on the calculator. So 2 to the 4th power should have been 16. 2 to the 3rd power is just 2 times 2 times 2, which is 8. 2 squared is 4, 2 times 2. 2 to the 1st is just 2. And then let's come back to this 0 power. That's going to be interesting. And then what about negative? I don't know. Let's talk about those in just a minute. So let's go on to the second column, the 10 to the powers. So the easy thing about tens is the 4 tells us how many zeros are on it, or you can use your calculator. So this would be 1, 2, 3, 4 zeros. So this is 10,000. This is 1, 2, 3 zeros, so 1,000. This is 2 zeros, so 100. This is 1 0, so 10. Okay, now we're left with these that I'm not sure if you knew how to do. Let's check it in your calculator, 2 to the 0 power. 2 to the 0 power is 1. So I want you guys to look over here at the properties of a 0 power. Here are some examples. Anything to the power of 0 is 1. I don't care if it's a negative, if it's a positive. Oh yeah, here it is, a letter, a variable, anything x to the 0, anything to the 0 power is 1. So that makes it really easy because 2 to the 0 is 1, 10 to the 0 is 1. And as you can tell, our numbers are getting smaller, smaller, smaller. So now what do you think they're going to get? A common answer would be now that they're going to be negative. But actually, we're going to have all positive exponents because if you think about it, a number squared is not going to be able to be negative because a number times itself is always going to be positive. So we want a smaller number that's not a negative. So a smaller number that's not a negative is going to be a fraction. So a fraction. So we're going to put 2 to the 1st on the bottom of the fraction, and we're going to put it under a 1. So 2 to the 1st, I know you guys did that here, 2 to the 1st is just 2. So this is actually just 2. So our answer is 1/2. So you're going to take whatever the base is, whatever that number is, and flip it to the bottom under a 1. So this is 1/2, this is 1/10. And it's to the exponent power becomes positive. So there's still a little 1 here. I'm just not going to put it because 10 to the 1 is just 10. Okay, so this base is going to flip to the bottom under a 1. However, we have this little exponent on here that is a 2 this time. 2 squared is 4. So actually, this one is going to be 1/4. 10 flips to the bottom here under a 1, but it is 10 squared. And so basically I want you to see that anytime you have a negative exponent, the whole thing flips to the bottom under a 1, but the exponent, now that it's flipped to the bottom, becomes positive. So 1 squared is 100, so this is 1/100th. Okay, and that actually fills in our next rule over here. Negative exponents. For every non-zero number a, an integer n, so we're just using a and n as a base and an exponent. Anytime it's negative, the whole thing flips to the bottom under a 1 and becomes positive. Okay, so look at our examples. 7 to the negative 3, 7 to the positive 3 flips under a 1 here. Okay, look at the next one. Negative 5 to the negative 2 becomes to the positive 2 after it flips under a 1. And now notice it didn't change the base. If the base was negative 5, it's going to stay negative 5. It just changes the exponent from negative to positive. Okay, so let's try a few of these. Anytime you feel like you've learned this lesson and you're good, push pause and try some of these on your own. They're not that hard, but I want you to practice them and then come back to this video and make sure you did it correctly. Okay, negative exponent, can't have a negative exponent, so we're going to flip it under a 1 and make it a positive exponent. But I do want you to go ahead and simplify it all the way. So 9 squared is 81. 9 times 9 is 81. So this is 1/81st. Okay, that's the most simplified. Remember, anything to the 0 power, I don't care if it's a positive number, a negative number, a variable, anything to the 0 power is just 1. So those are going to be super easy. 4 to the can't have a negative exponent. So I'm going to flip it under a 1 and make it now a positive exponent. But I do want you guys to practice working it all the way out. 4 to the third means 4 times 4 times 4. And if you don't know it, 4 to the third is 64. Or you could have typed out 4 times 4 times 4. Okay, anything to the 0 power is 1. Can't have a negative exponent, so I'm going to flip it under a 1. Now the negative 4 stays negative 4. However, this negative 2 becomes positive 2. So I'm going to work that out. Negative 4 squared means negative 4 times negative 4, which is positive 16. So this is 1/16. Okay, can't have a negative exponent, so it's going to flip under a 1 and become a positive 1 exponent, but 6 to the first power is just 6, so I don't even need to write the little 1. That would be not as simplified as just leaving it 1/6. Once again, can't have a negative exponent, so I'm going to flip it under a 1 and make it a positive exponent. 3 squared means 3 times 3, which is 9, so 1/9 is your final answer there. Okay, now I'm going to show you what happens if I squeeze a bunch of terms together. This is 5 as its own term. Think of looking at 5, I'm going to cover up the rest of it, by itself. 5 is its own term. A to the third is its own term. It's just happened to be getting squished or multiplied next to 5. And then b to the negative second is its own term. So when you look at this and you notice that there's a problem here, you can't have a negative exponent. The whole thing is not going to flip under a 1. Only this individual term is the problem. So the 5a to the third, b to the negative 2 is over a hidden invisible 1, right? All whole numbers, if I told you, give me the number 2, make it into a fraction, it would be 2 over 1, right? So all of these terms, the whole thing is technically over a hidden invisible 1. So we can make anything we want into a fraction. Let's say this was a fraction. We're going to flip the b to the negative 2 to the bottom and make it now a positive 2. And now it is gone from there, and now our answer is fine. We can leave a 5 up top and an a to the third up top, but we can't leave a b to the negative 2 because that, you can't have a negative exponent. It's got to flip to the bottom under a 1, and if there was a 1 up here, it would be getting multiplied by a 5a to the third, so that can just stay 5a to the third. So my final answer is, I'll just rewrite it here, 5a to the third over b squared. All right. Oh, we haven't done one of these yet. I'm glad this is here. What happens if your negative is already on the bottom? Guess what? It is going to flip to the top because it would technically be saying 1 over x to the negative 5th. So we would be flipping it, and making this now a positive 5. But anytime you have 1 over a number, this is going to do the same thing as coming back to the top. So if you have a negative on the top, like a, it's going to flip to the bottom and become positive. If you have a negative on the bottom, it's going to flip to the top and become positive. So, and I don't need to put it over 1. I mean, you can, but it's the same thing as when back over here when I said the whole number 2 is the same thing as 2 over 1. It's more simplified to just call it 2. So it's going to be more simplified if it's up top just to call it x to the 5th. But technically we have flipped it to the top and a 1 flipped back to the bottom. Okay, so this technically, remember, is over, it's a whole number, it's a whole expression, so we're going to flip it to the bottom and make it positive under a 1. And that's all you need to do there. Make sure your exponent becomes positive now that you have flipped it. Okay, here's another one. It was on the bottom. We're going to flip it up to the top and make it positive. And again, you don't need to put it over 1, even though we did move it up to the top. That's just understood. Okay, let's look at E. 4 is its own term. 4 is doing fine. 4 you can leave up top. Remember, we're assuming that since this is not a fraction, it's all over a hidden invisible 1. 4 is going to stay put. However, c to the negative third is a problem. It's going to have to go to the bottom, and it's going to become a c to the positive third. Now it's gone because I moved it. B, though, is fine. B is totally fine. It's not negative, it can stay there. So my final answer is 4b on the top over c to the third on the bottom. All right, F. A to the negative third is the only problem. It's going to have to flip to the top and become positive. So it would technically be 2a to the positive third on the top. But again, anything over 1 we can just not show. So we're just going to call this 2a to the third. And then the last one of these, the only issue we have here is that n to the negative 5 is going to have to flip to the bottom, and there's going to be nothing left up top. And even though that's fine when you have a 1 on the bottom to make it disappear, if you have a 1 on the top, it can't disappear. That is a numerator that needs to stay. So we are going to move the n to the 5th to the bottom, and it's going to join the m squared that was already there, and now my n is going to become positive. So 1 over m squared n to the 5th. Okay, the next section is evaluating an expression, and this time I'm going to tell you what s is. It's 2. So when you see s here, you should be thinking of 2 to the third power. And then I'm going to tell you that t is a negative 3. So when you see this t here, I want you to think of it as a negative 3. So let's just rewrite this and fill in what we know s is and t is. So this is 3. This is 2. I'm going to put the little times there. 2 to the third. And then did you guys notice that this is a negative exponent? So I'm going to bring it down to the bottom and make it positive. And our t, instead of t, it's going to be negative 3. And I want it to be squared because it was a negative 2, but when I flipped it to the bottom, it became a positive 2. So now you guys are just going to solve this. I hope you remember the order of operations. You have to do exponents first. So this is actually 3 times 2 times 2 times 2, which 2 times 2 times 2 is 8. Negative 3 squared is negative 3 times negative 3, which is positive 9. 3 times 8 is 24. I don't think 24 divides by 9 nice and neat. Oops, 24 divided by 9. It doesn't, but I wonder if we can simplify it. 2 2/3. I'm okay with you either calling it 2 2/3 or you can just leave it 24/9. So either of these is fine. I don't care. Okay. Oh, we're doing some more of these. So n is negative 2, w is 5. So n is negative 2, w is 5. Okay, so this is a problem because you can't have a negative 4 on the top, so I'm going to flip it to the bottom under a 1, negative 2 to the positive 4th, and the 5 to the 0, it just is 1. 5 to the 0 is 1. Anything to the 0 power is 1. So 1 stays put. This whole thing was originally over a hidden invisible 1, so this guy is going to stay up top. So I'm going to leave it. 5 to the 0 is 1. Negative 2 to the 4th power let's put this in your calculator. And did you see that I put it in parentheses? You need to actually type in the parentheses. Otherwise, you're going to get a weird number. So type in a parenthesis and then -2, close your parenthesis, to the 4th power, the little caret key. 4th power is 16, positive 16. So this whole thing is 1/16. All right, the n is -2, so this is a -2 to the -1. We're going to have to flip that to the bottom. W is 5, so 5 squared is fine where it's at. There's nothing wrong with having a positive exponent, so it can stay. But this one is going to join it on the bottom. So I'm going to put it under a 1. We already had a 5 squared down here, and now my -2 to the now positive 1 is going to get flipped to the bottom. So let's simplify this. It would be 5 squared is 25. -2 to the first is just -2. So 25 times -2 is -50. So this is going to be 1/-50, or the negative doesn't have to go on the bottom. It could just be out front, because -1/50 is the same as 1/-50. Okay, I'm not even going to say that n is -2 because we see that it's to the 0 power, and anything to the 0 power is going to be 1. W is 5. This is 5 to the 6th power. There's nothing wrong with this equation except I need to simplify it. So you can have a positive exponent. So 5 to the 6th, I have no idea what that is. 5 to the 6th power is 15,625. So 1/15,625. That is a tiny fraction. And last, I want to make sure you know these are two separate terms down here. So the 1 for now is fine. We'll leave the 1 up top. N is -2, and W is 5 to the -1. So this guy can stay. You can leave it down here. The number can be negative. It's just that the exponent cannot. So I'm going to flip just the 5 up top. So it is going to be 5 to the now positive 1, because when you flip it, it becomes positive. And -2 is still down there on the bottom. And just remember that anything to the 1 is just itself. So I'm okay with you circling this as your final answer, 5 to the -2, or sorry, 5/-2, or that's the same thing as dividing. So 5 divided by -2 is -2.5. I don't care. You can leave it 5/-2 or -2.5. Okay, the bottom section is a U-try. This is the last of our new stuff, so you're just going to simplify these 4 and then try these 2 where you're plugging in 2 for A and -4 for B. And then I want you guys to push play and make sure you did them all correctly. Okay, if you are ready to check, 2 to the -5 is going to flip to the bottom under a 1, and then it's going to become a +5. So 2 to the 5th power, I don't know what that is. 2 to the 5th power is 32, so it's 1/32. M to the 0 is 1, because anything to the 0 power is 1. 5s squared t to the -1. The only problem I've got here is you can't have a negative exponent. So it's going to flip underneath this 5s squared, and it's going to be 5s squared over t to the +1. I'm just going to leave it off because that's more simplified to leave a 1 off. And that's it. That's all we know. So 5s squared over t should be this final answer here. All right, and then the last one, the only issue I've got is you can't have a